Teacher Sam tells me that you guys got to this point at the end of your last lesson, but you didn't get to finish it up. So if you would like to take a screenshot of this full answer, please feel free to do so. There's a few things in this which are going to be helpful for the questions that we're dealing with today. So if there's anything you don't understand while you are reading through this, please let me know. You can send a message. You can send it directly to me if you're embarrassed, but let me know if there's something you don't understand. And also, can we just have a moment of appreciation for how neat Teacher Sam's handwriting is, because it's blowing me away. It's so neat. So I'm apologizing now for the handwriting that you are about to see, because it doesn't look like this work of art. Okay, we are going to do a similar thing to the thing we did last time I substituted you guys. I would like you to have a look through those emojis, and I'd like you to find an emoji that represents how your day went today. Doesn't matter what it is, find it, post it for me. I will post mine. Let's see. I need to find a good one. Probably this dude. Okay, post an emoji. Let me know how your day went, so that I know you all know how to find the chat. You can all give me answers as we go through this lesson. Keep them coming. The upside down smiley face is like my favorite emoji. Keep them coming, guys. I need to know you know how to get onto this chat. I promise I will stop singing when you send me pictures. Nice. Cool. Okay. All right, for those of you who have just joined, I'm Teacher Jen. I'm subbing in for you today and next week, Saturday, for your boot camp. This is where you guys ended with your lesson on Mondays. If you'd like to take a screenshot, please feel free. And we are going to jump into some extra questions today. Get those hands ready to give me answers, either with hands ups or writing your answers in the chat. I'm going to be harassing you for answers tonight. Make sure you're all awake. You only have to keep your brains working for another 55 minutes, and then you can turn them off. Okay, let's jump right into it. Oh, gosh, guys, I love analytical geometry. You know why I love analytical geometry? Because, not that anyone asked, I'm going to tell you anyway. So analytical geometry is the way that it's written in exams and tests is quite cool. It kind of, they scaffold the questions for you. So they always start with things that will help you later on. They're trying to give you advice basically as you're going along the question. So it's to help you in your later, as the questions get harder, the stuff you did before is supposed to help you. So it's quite nice. Kind of giving you like little helping hands all throughout the question. Okay, before we panic and look at any of the things here, we're going to quickly read what information they've given us. So they've told us that we have got L, which is -4 and 1, S, which is 4 and 5, and N, which is -2 and -3. And they are all vertices of a triangle. They've also told us that this triangle has a 90-degree angle, which is useful for us to know. Okay. first thing they would like us to do is calculate the length of SL. When we are asked to calculate the length of something, what does our brain need to think of? Which formula do we need to think of when we're being asked for the length? Distance. Beautiful. Okay, good. So we see length of SL. That means we need to use our distance formula. Okay, remember your distance formula will be on your formula sheet, so it's not something you need to learn off by heart. So I'm going to write it up here for you. Your distance is going to be the square root. Oh, gosh, that line is just a little bit too wonky. Slightly better. Okay, and it's going to be x2 minus x1 squared plus y2 minus y1 squared. Cool. I always find writing the formula as our first line, it helps. It makes it not a blank space anymore, which can sometimes be intimidating. And also it kind of tells us exactly what we're going to do next. So now we know we need to find our x's and our y's. Okay, we are looking for the distance of SL, which means we care about L and we care about S. The next thing I recommend you do, you might think I'm being silly by doing this. It takes 15 seconds, and I promise it helps stop so many silly mistakes that you will be grateful that you do this. Just take a moment to label things. So I'm going to label this x1 and y1, and I'm going to label this x2 and y2. Less than 15 seconds that took, and I promise it helps you. Okay, so we're now just going to put what we need to put from those points into our formula, and you are going to give me a glorious answer of what our distance is. And it says it wants the answer in third form, which means you're going to give me an answer with a square root. So substitute those in, pop it into your calculator, tell me what answer you get. If you're embarrassed, send it to me as a direct message, and I will let you know if you are correct or if you are incorrect. Be careful with your negative signs. Just as a little helping hand there. I don't want to write anything on the board just yet because I don't want you to see. There's a trap that you may fall for, and I want to see if anyone falls for it. Oh, I like that answer. Oh, happy dance over there. That's great. Let's see if anyone else gets that. Are we agreeing? Nice. Good job. Okay, so let's substitute our points in. And remember, you get a mark for showing that substitution. So x2 is 4 minus x1. This is where we have to be careful. We are minusing a negative number. So you can actually just write 4 plus 4, or you can write 4 minus brackets negative 4. This over here is one of the most common mistakes in these questions, is they don't put it in brackets and they just say 4 minus 4. Okay, so if you made that mistake, that's very normal. Just try not to do it as you move forward. Y2 is 5, Y1 is 1, and we're going to square that. We're going to chuck it straight into our calculator exactly like that, and we will get the answer 4 root 5. And if we want to be fancy, we can say units. You won't lose marks for not writing units, but let's just be fancy. Okay, so 4 root 5. Nice job. So for this, you would get a mark for showing that you know how to substitute. Sometimes you'll get 2 marks over there, depending on how much the question is worth, and then a mark for your answer. All right. let's have a look at question 3.2. Question 3.2 would like the gradient of Sn. Who can help me out here? Now I'm wanting the gradient of Sn. What can I do? I'm open to all suggestions. Yes, hi.
Are we not going to use the formula y2 minus y1 over x2 minus x1?
That is exactly what you're going to do. Well done. 5,000 stars for you. That is 100% what we're going to do. So we're going to say our gradient is equal to y2 minus y1 over x2 minus x1. Let's label these again. So I'm just going to say x1 and y1. It doesn't matter. That could also be x2, y2. That's not important. And then x2, y2. Okay. So our gradient is going to equal. Pop it into your calculators and tell me what glorious answer you get. You should get an answer as a fraction. Don't turn it into a decimal. You always want to keep your gradient as a fraction. Yes, nice. Yes. Okay, so y2, I'm going to say -3 minus 5 over x2, which is -2 minus 4. And that gives us the answer m. I'm actually going to write it next to it. I know I shouldn't, because we always like working under, but I'm just going to work next to it so that we can see. So therefore, m is going to equal 4 over 3. Remember, keep this as a fraction. Do not turn it into a decimal. Nice job. Okay, now 3.3. Remember what I said at the beginning of this lesson. Analytical geometry is scaffolded. What we do in the question before helps us in later questions. So keeping that in mind, let's read through this question. Calculate the size of theta, which is the angle of inclination of Sn. So we're trying to find that theta. We know that it's the angle of inclination of Sn. What am I going to do? Guys, you are so smart. Yes, absolutely. Tan theta is equal to our gradient. Okay, 100%. Let's write that out. So tan theta is equal to our gradient of that line. All right. So in this case, tan theta is going to equal 4 over 3. What do I do now that I'm trying to find theta? I'm trying to find this dude over here. What do I need to do in my calculator in order for me to find theta?
Arctan.
Yes, arc. Beautiful. Okay. How do we do that? What do we put? What do we use on our calculator to help us get that?
Shift then tan.
Yes. Okay. So we're going to say shift 10, and then we're going to pop in our fraction, which is 4 over 3, and we should get a glorious answer. So I can jump straight to saying, so in your calculator here, you're going to use shift 10, and then you're going to put in your fraction, and you should get a lovely answer of theta is equal to 53,13 degrees. Please, can you all try and do that for me, just to make sure that you are getting the correct value for theta and that your calculator is on the correct setting? My cat is back. This is Charlie. Cool. Happy dance. Okay. We're actually going to do 3.5 before we do 3.4, just because it's right here, and it's going to help us as we work through it. You can take a screenshot then of all of these. 3.5 is asking for the area of this whole triangle. Okay. What is the formula that we use to find the area of a triangle? Don't overthink it. Don't like jump into like trig things. Think grade 8, grade 9. Yes, beautiful. Direct message, 100%. Your area is half of your base times your perpendicular height. Okay, so in this case, we're going to care about, let's just get rid of all of this so that we can talk about what we need to talk about. So in this case, all we care about is our base and our perpendicular height. Now, it doesn't matter which one of those is your base and which is your height. It's not important as long as those are the two lines you're dealing with. Okay, we already know that SL is 4 root 5. We worked that out in 3.1. So we need to work out what LN is because we don't know what LN is. And once we work out LN, then we can work out the area of our triangle. So that is my helping hand to you. I'd like you to figure out what LN is. I'd like you to figure out the area of this triangle. And then I would like you to give me your glorious answer. And let's see, I'm going to give you 1, 2, 3, 4 marks for this question. Let's see who can get 4 out of 4. Give it your best go. I will tell you that if you don't get a nice answer, then something's gone wrong. And if you want to check your answers along the way, you're welcome to send me a direct message. I can let you know if you're on the right track. So if you want to let me know what you get for LN, please feel free. Oh, okay. Direct message. I see you, and you're 100% right. Good. Looks like you're getting a 4 out of 4. Keep those answers coming. I am liking what I am seeing. Nice. All right, let's jump into it. So we're going to start by figuring out what LN is. So LN, we're going to use our distance formula again. I'm looking at, so I'm going to say x1, y1, x2, y2, a terrible x2 anyway. Okay, so we're going to say x2, which is -2, minus x1, so minus -4, all squared, plus -3 minus 1 squared. And that gives us the answer of 2 root 5. Okay, so now we know what LN is. It's 2 root 5. Once we have that, we can go to our area formula. So area is equal to half base times height. So half base, 4 root 5, times height, 2 root 5. Chuck that into your calculator exactly like that, and you'll get 20. Marks, let's see. 1 for substituting in to get your distance, 1 for getting ln, 1 for substituting into your area formula, and 1 for your 20. Let me know how you did here. If you got 1, 2, 3, or 4 out of 4, let me know. Remember, you're welcome to send it as a direct message. Yes, 4 out of 4. Keep them coming. Let me know how you did. Nice job, guys. Okay, good, 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 good. Okay, we've got one more question on question 3, and then we're going to jump into a different set of questions. So the last one here, I don't think I need that, so I'm going to do that. Determine the equation of the line which passes through L and is parallel to SN. Write your answer in the format y equals mx plus c. Okay, so they've told us some good things here. They've told us the format they're wanting it. They've told us that the line passes through L. So let's just take a moment and see what the coordinates of L are. So we know that that's that. Okay, so L is -4 and 1. Okay, we know it goes through L. The next thing it's telling us is that it is parallel to SN. Okay, so that's this line over here. It is parallel to that line. So we're going to have a line that looks something like that, basically. What important piece of information do we need to take from the fact that it's parallel to SN? Because remember, they only tell you information that helps you. So everything they tell you is important. Beautiful. Yes. Parallel lines have equal gradients. Good. Good, 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 good. Okay. Let's just write that in here for anyone who doesn't remember. Parallel lines have equal gradients. Okay. So we know already that the gradient of SN is 4/3. We worked that out earlier. So we know that the gradient is going to be 4/3 because it is parallel to SN. Okay. We've actually done a lot of the hard bit already. Let's say, though, that we're in a test situation. You've gotten this far. So you figured out what your gradient would be, and you know that it goes through L. Where do I go to from here? What's my next step? Okay, sub in the L coordinates. What am I subbing it into, though? Good, okay. So we're going to first put in the gradient. So we're going to say, cool, we know we've got y equals 4/3x plus c. We need to figure out what c is. And in order to do that, we need to sub in another point. So we are going to sub in L, which is -4 and 1. I'd like you all to give that a go. Sub it in and let me know what your final formula is for this line. Sub in your points. I'll show you 2 different ways you can go about this. You don't actually need the picture from here. Here we go. You can do a fraction route or you can do a common denominator route. Doesn't matter. You'll get to the same endpoint. Okay, we're getting some answers coming in. I can confirm that one of the direct messages of the answers I've gotten is correct. Give you a couple more minutes. All right, let's sub in L. So my Y value is 1 and my X value is -4 plus C. So I land up with 1 equals -16/3 plus C. When you get to this point over here, you can just move your fraction over and then use your calculator if you would like. So you can say 1 plus 16/3 is equal to C. And if you chuck that into your calculator, you should get 19/3 is equal to C. Okay, so that's one route. The other route of doing this, if you don't like working with fractions, which lots of people don't, so you're very like in good company if that is you, is at this point, so 1 is equal to -16/3 plus C, we could get a common denominator. Okay, so remember at the moment, those are both over 1, which means we would need to multiply both of those by 3 so that they all have the same denominator. Okay, so we would land up with 3 is equal to -16 plus 3C. We're going to move that 16 over. So 3 plus 16 is equal to 3C. 19 is equal to 3C. So 19/3 is equal to C. Let me see. My answer would give me negative. Oh, as a whole number, totally fine. Totally fine to write it as a mixed number. Not a problem at all. Okay. Remember, once you've gotten to this point over here and you have your C value, you haven't answered your question. You haven't gotten your final mark. They want you to write it in standard form. If you don't write it in standard form, you do not get that last mark. And it is a very irritating mark to lose. So always remember to do it. Y is equal to our gradient 4/3x plus our C 19/3. Done. Easy peasy lemon squeezy. Please feel free to take a screenshot if you would like. And then we're going to jump into our next set of questions. Also, don't be scared to ask me questions. If there's something you don't understand, just pop it in the chat and I promise I'll answer. Okay, let's move on down. Okay, let's make this a little bit easier for us to see. Okay, so we've been given a diagram. We've given point A, point B, point C, point E. Now there's some fancy words that are used here. Line BC is produced to H. That is a very fancy way of saying that line BC carries on to point H. That's all that means. It is literally all that it means. It doesn't mean anything fancier than that. All it means is BC continues to H. So C is a point on line BH. That's what that means. Okay, cool. AB and AC intersect the x-axis at F and G. Cool. And the angle of inclination of AB is 81.87 degrees. Cool. Let's jump into these questions. First question. Calculate the gradient. So we already know from our previous work that the gradient formula is your change of y over your change of x. Okay. And they are wanting the gradient of BE. How am I going to work that out when I don't know my coordinates for B? What can I do? Okay, so we can't actually use tan theta is equal to m in this particular situation because we don't have theta of BE. We can do that later on, but we can't do it for this line because we don't have theta. Ah, yes, collinear points. Yes, excellent. Okay, guys, they're all the same points on the same line. Points B, point C, point E, and point H are all on the same line. Because they are all on the same line, we can use any of those points to find the gradient. Okay, so I'm going to use C and E. So I'm going to say x1, y1, x2, y2, and I'm going to sub it into my formula. So m is equal to 0 minus -2 over 12 minus 4. So we're going to get 2 over 8. So we'll get 1 over 4. So collinear points are very important to keep a note of. They specifically will put a question like this into just to throw you off, because you'll all look at B and think, I can't use B. I don't know what B is. And then you panic. But we're not going to panic because we're brain buffs. And we can see that they are all collinear. All right, nice. Okay, for 3.1.2, someone already gave you the answer as to how to do 3.1.2. 3.1.2, you are looking at the gradient of that green line. And someone in the chat has already helped you. So I would like you all to give that a go. And I would like you to tell me what your gradient is. You should get a nice whole number if you rounded it off. And just pop your answer in the chat for me, or you're welcome to unmute and let me know when you got an answer. And we can see how you did. Think about a question we did earlier in this lesson, but we're going to do it in a slightly different way. Let's have a look. Good, good, good. Tan theta equals m. We know what theta is. Beautiful. I love that answer. 100%. Nice job. Let's write it on down. Okay. Tan theta is equal to our gradient, okay, of whichever line we're looking at, of the line of the angle of inclination. So in this case, tan of our angle of inclination is 81,87 degrees, and that is going to equal the gradient of AB. Okay, this, we don't have to do anything fancy in our calculator. We don't have to push shift. We don't have to do an inverse. We literally can just put it in exactly like that into our calculator, and you should get a nice answer of 7,00 or something. So we can just say our gradient of AB, or you can just say M, is equal to 7. Done. Hopefully, like, the more that you guys are doing these questions, the more you're sort of thinking, oh, I think I should do this, or oh, I should do this. Because as soon as you start making those connections, analytical geometry becomes so much easier. Okay. Let's have a look at 3.2. So 3.2 is asking for the equation of BE. I'm actually going to do it in yellow because we've already got BE highlighted, and it wants it in the form of y equals mx plus c. You have already worked out the gradient of it, and we have done a question very similar to this in the last question that we did. So I'm not going to give you any helping hand. I would like you to work this out, and I am going to give you, how many marks? I'm going to give you 1, 2, I'm going to give you 3 marks for this question. 3 marks and 3 minutes. So at 1840, we're going to go through the answer, and we're going to see how many people get 3 out of 3. Two minutes left. Oh, we're getting our first answers coming in. I'm liking what I'm seeing. I'm seeing some 3 out of 3s in their futures. Keep those answers coming. Oh, my little moon pie, you used the wrong line. You worked out the equation of AB, not BE. Good. One that just came in now, 100%. You got about 1 minute left. Cool. Let's go. Okay. So, what color should we do this in? What color are we normally? It looks like yellowy color. Let's use that. All right, we're going to start with the same way we did the previous one, and we're going to substitute in our m. Okay, so we've got y is equal to 1/4 x plus c. At this point, you can sub in c or you can sub in e. It doesn't matter. Generally, it's easier to use one of the intercepts. So I'm going to sub in e, which is 12 and 0. Okay, so y is 0 and x is 12, and I'm looking for c. So 0 is equal to 12 over 4, which is 3, which means c is equal to -3. Now that I have found c, I can write our full formula. So I can say y is equal to 1/4 x minus 3. For the answer that came in that looked like this, y is equal to 7x plus 84. That's absolutely right, but for the green line, not for the yellow line. So just always be super careful to read which line you have to work out, because you did the right things. You just did it for the wrong line. Okay, marks for this. Let's see. I'm going to give you a mark for subbing in your X and Y, a mark for getting your C value, and a mark for your final equation. How did we do? Did we do 1, 2, or 3 out of 3? Let me know. Lots of 3s. Nice. That's okay. That's okay. If you subbed it in incorrectly, you may still be given 1 mark for continued accuracy, depending on how kind your marker is. Hope for a kind marker. Okay. Let's look at question 3.3. Question 3.3 is asking you to find the coordinates of B. Okay, so we need to find out what those values are. This part over here, where they're saying K is less than 0, all that that's telling you is that K is a negative number. Okay, so don't look at that and think, oh my gosh, this is an inequality. I don't know what to do. I'm panicking. I'm just going to leave it. Don't think like that. It's just telling you that it's a negative number. So you can do it as a normal equation and just make sure that you get the correct answer for K. So who has a suggestion for me on how we can go about finding out what the values for K are in this situation? There's multiple different things you could do. But all suggestions are welcome. Just imagine you were in a test or an exam and you had to answer this question. What would you do? If it's panic and close your test, that's also okay. I want to know what you would do. You just tell me. You are reading this question in an exam. What do you do? Panic. It's normal. It's a very normal response. Okay, let's think. Try to find the intersection points. You could absolutely try and find the intersection. The reason I would not suggest that road is because you would have had to find the equation of line AB as well, which we have on the board now because someone had already done it. But normally you wouldn't have that green equation. So you would have to do multiple steps in order to do that. You could though, so it's a good suggestion. Who has any other suggestions? Equate the equation of AB and BE. Yes, okay, so that's that same idea as Emmanuel. So finding that point of intersection where these two lines meet. Again, though, you would need to have the equation of AB. So how could we do this only knowing the equation of BE? Okay, use the gradient of AB. You could absolutely do that. But you don't even need to solve simultaneously. You'll see why now. These are really good suggestions though. And do you see how if we take a moment to move past the panic, our brain does actually start thinking of really good suggestions for us. We've just got to trust our brains a little bit. Okay, let's have a look here. Some of these suggestions that came in are use a gradient of AB, use the equations. All of those are great suggestions. I'm going to show you a couple different ways. Let's look at our equation BE. Okay, so we know, I'm going to just get rid of this because we're not going to do that question. We know that BE, the whole equation of the line BE, is y equals a quarter x minus 3. And we know that because we've just worked it out. And remember, with analytical geometry, they help you as the questions go. For the answer that just came in now as a direct message, we can't use C as a midpoint because they didn't tell us that C is a midpoint. And if they don't tell us that, we can't assume it. Okay. So why don't we just sub in B? What happens if we do that? If we sub in K and K, see what happens. K is equal to a quarter K minus 3. Okay, that's not so bad. Let's get a common denominator going. So 4K is equal to K minus 12. So all I did over there was these had a denominator of 1, and so I multiplied those by 4. 4K. Oh, I'm in the wrong color. 4K minus K is equal to negative 12, which means 3K is equal to negative 12, which means K is equal to negative 4. How cool is that? So that's one way. I'm going to use one of your suggestions for another way. So one of your other suggestions was use the gradient, and you said the gradient of AB. So you knew that the gradient of AB was equal to 7. Okay. So if I did that, I could say 7 is equal to 10 minus K over negative 2 minus K. And then I could work it out as an equation like that. You'll get to the same answer. So from here, we would say 7 times negative 2 minus K is equal to 10 minus K. Same situation. Isn't maths cool sometimes? I think so. I'm a maths nerd, yes. Does anyone have any questions about this that you're unclear about? I'm going to zoom out so you've got the whole question on the board, and then please feel free to take a screenshot. You had really good suggestions with what you were giving me, but hopefully this helps. What if we were solving for X and Y instead of K? So the thing is, we already know that this is X and this is Y. So the coordinates for B are -4 and -4. Those are our X and Y values. We just know that they are the same value as each other because we've been told that they are both K. So we can just substitute K in because it's the same. You could have just used X's though. You could have said X equals a quarter X minus 3. Or you could have said Y equals a quarter Y minus 3. Same. Is the second part in green the last line? Yeah, that would be 10 minus K. So this would now be -14 minus 7K is equal to 10 minus K. And then you would solve it as an equation. You're most welcome. Thank you for your questions, guys. Does anyone have anyone more before I move down? Cool. Okay, we don't have a huge amount of time, but I'm hoping we can do these first 2 questions. Okay. Let's see how our time goes. So what we've got over here, I'm going to try and simplify it a little bit just because of our time. So we've got a trapezium. They have told us it's a trapezium, but we can also see it's a trapezium because that line is parallel to that line. Okay. And then they've told us what our different points are, and they've told us that angle PEF is theta. Cool. Good place to start. First question is write down the equation of PR, okay? So I want you to have a look at PR. I'm going to highlight it. So we are looking at this equation over here. So that line. And I want you to look at something very important about their Y values. And then tell me what the equation of PR is. Or tell me something you notice about those Y values. What are they to each other? I promise I'm not trying to trick you. Yeah, they're the same. They are exactly the same, okay? They have the same Y value, okay? If they have the same Y value, what that's telling me is that line is parallel to my x-axis. It means that wherever I go on this line, so at this point over here, I don't know what my x value is, but I know that my Y value is going to be 5. If I carried on that line over here, I don't know what my x value is, but I know that my Y value is 5. So it doesn't matter what point I am on that line, I know what my Y value is, even if I don't know what my X value is. Because of that, we can just write it as Y is equal to 5. If we had a line that was vertical like this, they would all have the same X value. So let's say this was like -7 and 4, and this was -7 and -6. Then that would be X is equal to -7. So when we have a line that is vertical, it's going to be X is equal to something. And when we have a line that is horizontal, it's going to be Y is equal to something. Okay. All right, last question of the night, and then you can all turn your brains off. Calculate the gradient of RS. This is a nice, easy question. There is nothing tricky about it. Calculate the gradient of RS. And give me your answer. And once you give me your answer, that is the last. You have to use your brain this evening. I've put everything you could possibly need on the screen. Chuck it into your calculators. Give me your answers and end off our lesson on a great brain buff note. Okay, getting some answers coming in. Keep them coming, keep them coming. Nice. We are all in agreement. I love it. Okay. So we're going to say our gradient is equal to -7 minus 5 over -3 minus 3, which is going to give us a -12 over -6, which gives us +2. So your gradient is 2.